This is Lab 25, Example 1. We have the system of equations, 6x plus 5y equals 13, and 2x plus 2y is equal to 5. For part A, we want to create the coefficient matrix. For the coefficient matrix, we're only going to pay attention to the left-hand side. These are just constants on the right-hand side. We're going to pay attention to everything that's in front of each variable. So we're going to create a matrix that's going to be 2 by 2. For the first row, we're going to be dealing with the first equation here. And we're just going to write the numbers in front of our variables. So the first row is the first equation. So we have 6 and we have 5. And for the second row, we have the second equation. We have 2 in front of x and we have 2 in front of y, so we have 2 and 2. Now you notice that each row corresponds to each equation without the right-hand side. And each column corresponds to what's in each variable, so to the coefficient that's in front of each variable. So this is the x column and this is the y column, like that. So this is our coefficient matrix. For part B, we want to find the determinant. The first way we can find it is by hand, because we have a 2 by 2 matrix. If we have a 2 by 2 matrix, that's in the form of A, B, C, and D. The formula to find the determinant D is equal to A times D subtract C times B. So we can find this algebraically by following this formula. This is going to be 6 times 2, subtract our C, which is 2, times 5, which is B. Oh, I wrote C instead of 2. This is 2. And this is 5. So 6 times 2 is 12, 2 times 5 is 10, and 12 minus 10 is equal to 2. So our determinant is 2. We can also find this using a calculator. So if we get out our calculator, press on, we're going to go to the matrix menu. That's going to be second x to the negative 1. We're going to scroll over to the edit tab. We're going to press on any of these matrices to edit. I'm going to press on A. There's something already there. This is a 2 by 2 matrix. We do the rows times the columns. So it has 2 rows and has 2 columns. So we're going to change the size to 2 by 2. And you notice it changes the size of our matrix. So we're going to enter in all of our entries. We have 6, we have 5, we have 2, and we have 2. Now that you've done that, we're going to go back to our main menu. So you're going to press second mode to quit, back to your home screen. We're going to go back into our matrix menu by pressing second x to the negative 1. To find the determinant, we're going to scroll over to the math menu. Determinant is the very first option there, so we're going to press enter. It's asking to input a matrix to find the determinant of, so we're going to go into our matrix menu one more time, press second x to the negative 1. And under the names, we're just going to pick the matrix we want to find the determinant of. I'm going to choose A, and then press enter one more time, and it gives us the number 2, which we found earlier to be true. So we know that our determinant is 2 via algebraically and via calculator. So we're going to move on to part C. Part C asks to find the reduced row echelon form of the augmented matrix. And then it asks, is the system consistent? So the first thing we want to do is find the augmented matrix. Previously we found the coefficient matrix where we ignored the right-hand side. In the augmented matrix we're going to include the right-hand side. So our augmented matrix is going to be 6, 5, and it's going to include the right-hand side, 13, 2, 2, and 5. So this is our augmented matrix. The first row is the first equation, the second row is the second equation, and this is the x column, this is the y column, and this is the right-hand side, which is just constants. So we're going to find the reduced row echelon form of this. We're going to do this using our calculator. It is possible to do it by hand, but is a bit more complicated. So we're going to go back into our matrix menu, second x to the negative 1. We're going to scroll over to our Edit tab. We're going to edit A. Our augmented matrix is 2 by 3. We have 2 rows, we have 3 columns. So we're going to change this to a 2 by 3 matrix. And then we're going to put in our entries. We have 6, we have 5, we have 13, we have 2, 2, and 5. So now that we've inputted our augmented matrix, we're going to go back to our home screen. So second mode to quit. And then we want to find the reduced row echelon form. So we're going to go back into our matrix menu, second x to the negative 1, go over to the math menu, and we're going to scroll down until we see RREF. So that RREF stands for reduced row echelon form. Press enter. It's going to ask which matrix you want it to do. So you're going to have to go back into the matrix menu, second x to the negative 1. Under names, you're going to choose the matrix you want to find the RREF of, which is A. Then press enter one more time, and it gives you a matrix as an answer. So let's write down that answer. So after we do RREF, our matrix becomes 1, 0, and then 0.5 I'm just going to write as 1/2, and then 0, 1, and 2. So first, before we ask if the system is consistent, we're going to ask what this means. Remember that if we can put something into a matrix form, we can take it out of the matrix form. So we had this, we moved this into a matrix form, and then we changed it into this form. We can now change this back into an equation form. What this matrix means, essentially, remember that this is the x column, this is the y column, this is the right-hand side, and this is the first equation, this is the second equation, ignoring that. Then we can rewrite this as the system where we have 1x plus 0y is equal to 1/2, and 0x plus 1y is equal to 2. So if this is the case, then another way you can just simply write it is that x is equal to 1/2, and for the second equation we have y is equal to 2. And this is actually the solution to our system of equations up here. We have x is equal to 1/2 and y is equal to 2. If we get a solution like that, then our system is in fact consistent. We didn't get anything like 0 is equal to 2 or anything in when we translated it back. So this system is consistent. I'll see you in part 2.